Alright, so number 9. Given an array of n strings, find the longest common prefix among all strings present in the array. So, prefix being the first few letters of a word, so we're just going to be comparing the beginning of the string and up until we no longer are getting the same character amongst all of them. So for this example here, where I have apple in April, if we just visually look, we can see that they all start with A and P, and then once we get to the third character in each string is when we start to diverge. And so to do this problem, we're going to be using a try node, and I have all the code written out for here, but just to kind of simplify it, we'll have a root, and then for each string we'll add all the characters. So the first string will just add every character, and then go to the second string, and there'll be a count at each index, and for anytime we have the same character we'll add the count, and then once we get something different we'll go off and add different children to each node. So I'll start off with apple and just put that in one character at a time, and we'll have an account initialized to 0, but then I add that and the count will be 1, and I'll add the second character, count will be 1 for that. And then we go to L, get a count of 1, then add the last one, and that's a count of 1. Alright, and then I'll do April next, and so we have A here, so we're just gonna add the count to that, and then second character is P. The second character on this node is also P, so I'll add 2 to that. Now I have R, and if we follow this, we get P, so I need to branch off and add R here. And then that will have a count of 1 since we're starting over. And then we'll just add I. And then L. And so that's what we get for the second string. And then last I'll add the third ape. So we have A. So I'll just increase the count to 3. Then we have P. I'll increase this again. Then we have E, and if we look, we have the options available to us is R and P, which E doesn't match either of those, so we're gonna have to add another child to this one and branch off and add E there, and then we'll give that a count of 1. Alright, so now that we've added all our strings, since we have 3 strings, we'll be going down, we'll basically be looking for anything that has a count of 3, since we have 3 strings here. So we'll start off at A, and then when we go down we have P, we have 3 there, and then when we go past that, if we look at all the options branching off from that, the count is, we only have a count of 1, so this is the end of our prefix. And then the time complexity of this is O of m times n, n being the length of the longest string, and m being how many, in our case we have 3, because we would only be we're only going down each one once. And then this space complexity would also at most be O of m, since yeah, if we happen to have all unique characters, that would be the maximum of the space that we would be using up for our tree.